Okay, let's unpack this. Imagine something like straight out of a sci-fi movie you might have seen. But instead of aliens, we're talking about vegetables, tiny seeds, actually. We've been diving into some really fascinating material about these seeds from Kerala, India, getting set for this, well, cosmic adventure.
It really is a captivating story. We've looked into how these, pretty humble seeds are about to become interstellar pioneers in a way. They're heading up to the International Space Station.
Wow.
Yeah. And it's not just some quick jaunt. This mission, it could genuinely revolutionize how we think about farming, both, way out there in space and crucially right back here on Earth.
Absolutely. So our mission for this deep dive is pretty clear. We want to trace the journey of these specific seeds, really get into the science, the stakes of space farming, and show you why this isn't just some, like, quirky experiment. It's got potentially huge implications for you.
And the whole thing kicks off quite literally from a very specific place and time.
Right, picture this. It's June 19th, 2025. You're down at the Kennedy Space Center in Florida. There's a SpaceX Falcon 9 rocket sitting on the pad, all ready to go. It's carrying astronauts, sure, but it's also got this very special cargo.
Exactly. Tucked inside that rocket are 6 specific varieties of vegetable seeds. And these aren't just any old seeds you'd buy at the store. They've been developed by the wizards, really, at Kerala Agricultural University, KAU, down in Veliani. Puran.
Okay.
Yep. And it's all part of the Axiom 4 mission.
Uh-huh.
They're headed for a 14-day stay up there, orbiting about 400 kilometers above us. It sounds kind of wild, sending seeds up like that, and honestly, it is pretty wild.
It really is. It feels like picking the best vegetables from the county fair and saying, all right, you lot, you're off to space camp.
Yep.
These are high-yielding, locally developed sort of heroes from Kerala's farms.
Agricultural heroes is a good way to put it. And we know the lineup. There are 2 rice varieties, Jyothi and Uma staple crops, obviously. Then Kanakamani, that's a type of cowpea. Kalakathara, which is sesame. Soria, that's brinjal or eggplant, as some might know it. And Veliani Vijay, a tomato variety actually named after KAU's home turf.
Gotcha.
Yeah. And they weren't just picked out of a hat. They were chosen very carefully for their genetic purity, how well they perform on Earth, and maybe some traits that might, help them handle the weirdness of space.
Yeah.
They're ready for some cosmic curveballs.
Which gets us right to the core question, doesn't it? Why? Why go to all this trouble and expense to send these specific seeds on a, 2-week space vacation 400 kilometers up? What is the point?
That's the multi-million-dollar question, isn't it? But it's definitely more than just showing off. The main scientific driver here is microgravity, that feeling of near weightlessness in orbit.
Right.
Scientists really need to understand exactly how that lack of gravity affects everything. Germination, how the plants grow, their overall toughness, Could being in space actually tweak these seeds, maybe give them some beneficial traits that just wouldn't happen under Earth gravity?
Interesting. And it's not just about understanding the seeds themselves in isolation, is it?
Not at all. If you think bigger picture, like long space trips maybe to Mars someday, or setting up a moon base, well, you need to grow food you just can't pack enough for years.
Right, the vitamins degrade and all that.
Exactly.
Yeah.
Packaged food loses its punch over time, so fresh nutrients are vital. Plus, there's a huge psychological boost. Astronauts talk about this, tending something green, something alive, when you're stuck in a metal can far from home. It matters.
Okay, but then there's the flip side, the part that connects back to us here.
And this is where it gets really exciting for everyone listening. If these seeds come back, and maybe they have developed some kind of, let's call them superpowers, maybe they sprout faster or need less water, or can handle heat or drought better.
Wow.
They could be a genuine game changer for farmers dealing with climate change right now. Imagine Kanakamani cowpeas that are naturally better in a drought, or Soria brinjals tougher against heat waves, all because they took a trip to space.
That would be incredible. So let's get into the science a bit more. Microgravity, it really messes with plants, right? Down here, gravity's like at their pumpas. Roots go down.
Precisely. Gravity tells them which way is down for roots and up for shoots. In space, that cue is basically gone. It's like they have to figure it out on their own. How do roots know where to get water? How do shoots find the light source consistently?
So this KAU experiment, Impact of Microgravity on Food Crop Seeds, is designed to study just that.
Exactly. And it's one of 7 Indian experiments flying on Axiom 4. They're not starting completely from scratch either. ISRO, The Indian Space Research Organization had a previous mission, BSLV-C60, back in December 2024.
Okay.
On that flight, they actually tested sprouting cowpea seeds, the same type as Kanakimani in microgravity, and they did sprout. Within 4 days, inside this little module called CERO-PS.
CERO-PS.
Yeah, compact research module for orbital plant studies. Seeing those little leaves pop out in space was a big step, kind of proof of concept.
Got it. So they do some initial work up there, maybe see if they sprout, but the really detailed analysis happens back on Earth.
That's the plan. The seeds and anything that might have sprouted are due back around mid-June 2025. Once they land and get back to the labs at KU and Zaliani, the scientists have planned this intensive, 4-month study period.
4 months, okay.
Yep. They'll compare everything, the space seeds versus identical seeds that stayed here as a control group. They'll look at germination rates faster, slower, more successful. They'll do genetic analysis, looking for any changes in the DNA, how genes are expressed.
So right down to the genetic level.
Absolutely. And nutritional content. Did space change the food value? Even the tiny microbes living on the seeds, how did space affect them? They're hunting for any measurable sign of those enhanced traits we talked about.
Fascinating. And who's the astronaut actually doing the gardening up there? Must be quite a job.
That important task falls to Group Captain Shubhanshu Shukla. He's the Indian astronaut on Axiom 4. He's an Indian Air Force pilot, very experienced, over 2,000 flight hours, flown things like the Su-30 MKI, the MiG-21.
Yeah, serious credentials.
Definitely. And his training includes specifically how to run these experiments in space. He's managing the main seed study, plus he's doing some related tests, trying to sprout methy, that's fig, Greek, and moon, green gram, right there on the station. Kind of like early tests for future space salads.
Huh, space salads. And I heard his menu isn't just freeze-dried stuff either. He gets some actual home cooking, sort of.
That's right. ISRO teamed up with India's Defense Food Research Lab, DFRL, and DRDO. They've developed a special menu for him. Things like anam, which is like a mango puree, moong dal halwa, gajar halwa.
Delicious.
Yeah, proper comfort food. It's a great reminder that food isn't just fuel, especially on long missions. It's morale, it's connection. And his experiments sprouting methy and moon tie right into that, figuring out how to get fresh stuff into future space diets.
It makes sense. Now, while this is huge for India, other agencies have grown plants in space before, right? Like NASA grew lettuce.
That's true. NASA's Veggie experiment grew lettuce quite a few years ago. But this mission is still a massive step, especially for India.
How so?
Well, it's the very first time that seeds developed specifically by an Indian Agricultural University, KAU, are flying on a human space mission. It's a crucial building block for India's bigger space ambitions, like the Gaganyaan program to send their own astronauts up, and eventually the Bharatiya Antariksha Station, their own space station.
Ah, okay. So learning to grow food is fundamental for those future plans.
Absolutely fundamental.
Yeah.
You can't have a long-term presence without it.
And India seems to be bringing its own unique angle to it, not just copying the lettuce approach.
Exactly right. While others focus maybe more on leafy greens initially, India is sending up these traditional staples, rice, cowpea, sesame, brinjal, tomato, plus experimenting with methi and moong. It diversifies the research and makes it super relevant for potential Earth benefits too.
Which brings us back around again to why you listening should care.
Precisely. That potential payoff back here is huge.
Yeah.
If these spacefaring seeds lead to crop varieties that are tougher, more resilient, Kanakimani cowpeas helping farmers through droughts, Surya brinjals handling heat waves better, that directly impacts food security, potentially globally.
And it sounds like this whole area, space agriculture, is kind of a quiet race happening now.
Oh, it's definitely heating up. NASA's still working hard. China's been growing rice on their Tiangong station. ESA's looking into it. Everyone knows that for long-term exploration, cracking space farming is essential. It's practical, but it's also, a bit of a status symbol. Growing the first salad on Mars, that'll be bragging rights.
Huh, for sure. But it's not easy, right? Space isn't exactly a welcoming garden. What are the big hurdles?
You're absolutely right, it's tough. Microgravity itself is a huge one. Water doesn't just flow down to roots, it can clump up, potentially suffocating them. Delivering nutrients is tricky. Then you need perfect environmental control. The right light, the right temperature, humidity, airflow. And then there's radiation. Way more cosmic and solar radiation up there without Earth's atmosphere protecting things. That can damage plant DNA.
So how do they manage all that in a small experiment?
It takes some pretty clever tech. They use specialized containers like that CROPS module idea. These things are designed to deliver water and nutrients right where they're needed without relying on gravity. They have tailored LED lighting, sensors everywhere monitoring temperature, humidity, CO2, oxygen, moisture. It's like creating a tiny, high-tech greenhouse specifically for space.
Okay, let's circle back to Kerala specifically. Why KAU? What made them the right fit for this?
It really seems like a perfect storm of expertise. KAU, particularly their College of Agriculture in Veliani, has this really strong history in breeding crops that are tough, high-yielding, and suited to challenging conditions like Kerala's own climate.
So they know these plants inside out.
Exactly. And they already had strong working relationships with ISRO and with IIST, the Indian Institute of Space Science and Technology, which is also nearby in Thiruvananthapuram. So you had the agricultural expertise right next door to the space expertise. It just made sense. Plus, there's a real innovative spirit in Kerala's farming community, too.
And this puts Kerala on the map in a whole new way, scientifically speaking.
Oh, absolutely. It showcases KAU and Kerala as major players in this really cutting-edge field of space agriculture. It proves big ideas and top-tier science can come from anywhere. You can really feel the excitement about this down there.
So when you trace it all back, from those lush fields in Veliani to this weightless environment 400 kilometers up, these seeds are true pioneers, an incredible journey.
This whole deep dive, it really highlights how human curiosity, combined with rigorous science and collaboration, is tackling these huge questions. Questions that matter for sending people to Mars, yes, but also for making sure we have resilient food sources right here for you, wherever you are.
So here's something to chew on, maybe. The next time you see a simple tomato, or maybe you're cooking rice, just pause for a second. Think about the tiny seed it came from. Could that humble seed's future, or its descendants' future, actually stretch all the way to the stars? Could a quick trip to space one day give the plants in your garden, or the crops on local farms, some kind of cosmic superpowers? Definitely something to think about.